We'll look at graphing cubic radicals, which will be very similar to graphing square roots. We'll start out looking at the parent function f of x equals the cube root of x. A few things to note here is our 0. When we have x equals 0, we're going to get 0. So our x and y intercept will equal 0. We also have our domain as all real numbers, so x is all real numbers. And our range is y is all real numbers. Looking at the difference between a square root and a cubic root, if I do the square root of -9 and the cubic root of 27, I'll get 3i for the square, which is imaginary, which we can't use, but I'll get -3 for the cubic. And so that's why we have all real numbers for the domain and range. Looking at the graph, we'll get this. It looks like a cubic function turned on its side. Notice that we have a xy intercept at 0, 0, and it goes on forever on the left and right side. Looking at how we change the domain, this will be very similar to our square roots. We have the cubic root of x minus h, where h will move the graph either left or right. If we look at the cube root of x plus 5, this will move the graph left 5 spaces. I wanted to remind you that the parentheses x minus 2 to the power of 1/3 is the same as the cubic root of x minus 2, and this will move the graph right 2 spaces. Looking at our graphs, we see the plus 5 in the blue. We'll move it to the left 5 spaces, and we'll see the minus 2 moves it right to the right 2 spaces. For our range, we'll have the cubic root of x plus k, where k will move the graph either up or down. So we have the cubic root of x close the root plus 9 will move the graph up by 9 spaces. If we have the cubic root of x in root minus 4, you may have noticed that I said in root. What that means is that we are ending the root. We are now writing outside of the square or cubic root. You may also see that with parentheses. Looking at the vertical shifts, again, we have a plus 9. This is the purple, moving it up by 9. So if we look at our 0, 0, we should get 0, 9, and going down by 4. And what I like to do is find where the cubic root would be a 0 and then find our y value, and that's a really good point to just off of everything else. The last graph we'll look at is the cubic root of x plus 4 minus 5, and we're just putting everything together, so that plus 4 will move the graph left 4. Once we get outside of the cubic root, minus 5 will move it down by 5. So if we look at these two graphs, we see that this moves down by 5 and over by 4. And again, finding that point where our cubic root would be 0 will tell me where it's at. So I'm judging off of this point.